It's the only way you can truly grow in this industry and develop your own style. So let's begin with the tattoo machines. I want to show you all the parts of a machine and what their functions are. Then I will talk a little bit about the differences between an outliner and a shader. I'm going to begin here with the frame. The frame is pretty much the backbone or the skeleton of the machine. This is what holds all the pieces into their place so they can function properly. It's also a conductor of electrical current that is provided by your power supply. Now, I'm going to start here at the top of the machine and work my way down. The first thing we want to look at is the front binding post and all of its components. The binding post serves two purposes. One is to hold the contact screw into place. Its second purpose is to provide electrical current to the contact screw that is generated by the coils. Also, the binding post, you'll find the outer screw and washer, which holds everything into place and allows you to adjust the angle of the contact screw. Next, you'll see two insulators, an inner and an outer. These insulators actually do not let the current that is meant for the contact screw to travel to the frame. Next to the insulators is where the wire connector is attached. Immediately after are spacers. These are used to space the contact screw directly over the front of the armature bar, which is the center to the core of the coils. Finally, the outer screw that locks the contact screw into place. This screw is usually made of Teflon. The reason for this is that this type of screw is not as hard as a regular screw. This will prevent damage to the threads of the contact screw while locking it into place. Now we move on to the next group of parts. Let's start with the armature bar. The armature bar is the part that actually moves the needle bar up and down through the tube of your machine. The magnetic energy that is created by the coils is what pulls the armature bar downward. Once the armature bar is pulled down, it breaks the connection between the contact screw and the front spring. Once this connection is broken, the back spring will pull the armature bar upward once again, making the connection to the contact screw. This will once again complete the connection of current, generate another magnetic field, and continue the process over and over. This is what makes the needle bar travel up and down at a very rapid pace. Next, we'll take a look at the front and back spring. The front spring is the part of the machine that makes contact with the contact screw. When these two parts connect, that is when the electrical circuit is complete. The rear spring is kind of like the pivot point of the armature bar. The rear spring is bent in a way to have the proper amount of tension applied to it to allow the armature bar to travel up and down freely. Different tensions can be applied to the back spring. Doing this will make the tattoo machine run differently. The next two little parts are the needle bar grommet and the spring O-ring. The rubber grommet on the front nipple of the armature bar is placed in the loop of the needle bar and will be attached to the machine. The spring O-ring placed just under the front spring and connected to the armature bar screw. This O-ring helps keeps tension on the front spring, so over time your front spring tension will remain pretty decent. The final part of this group is the rear spring screw and washer. This screw locks the entire armature bar group into place and allows you to make fine adjustments to the placement of this group over the top of the coils, allowing for very fine tuning of your machine. Moving along down the machine even further, we now get to the coils and the capacitor. If the frame is the skeleton, then the coils would absolutely be the heart and soul of your tattoo machine. This is the part of the machine that generates the magnetic field needed to make your needle travel up and down and obviously penetrate the surface of the skin. The coils come in a few different sizes depending on what kind of power you want provided to your machine. The size of the coil is determined by the amount of wire wrapped around its core. A liner may use 8 wrap coils when a shader may use 10 to 12 wraps to provide a stronger current to drive larger needle groups. The coil consists of a steel core. That core is wrapped by copper wire as seen here. The combination of these two things plus electricity will generate a magnetic field. Next is a capacitor. In a way, a capacitor is like a little battery. Although they work completely different, capacitors and batteries both store electrical energy. So basically, in a nutshell, the negative side of the capacitor accepts electrons that the coil is producing. The positive side of the capacitor loses electrons and allows current to flow toward the contact screw or positive side of the connection. Okay, moving right along, we'll now tackle the rear binding post. This piece is very similar to the front binding post in its functions of the tattoo machine. The difference between the front and rear binding post is the rear binding post does not hold the contact screw into place. It is actually the area of the machine that you would hook the clip cord up to. The clip cord is attached to the power supply that actually supplies the machine with the electrical current needed to make your machine run. Once again, you have the rear binding post, the spacers, the area that your wire connector is connected to, the inner and outer insulators, and the binding post screw which holds it all together. Now we'll get to the last part of the machine that's right up here in the front. This is your tube vise and tube vise locking screw. And of course, this is the area of the tube that will be locked into place. So next thing I want to discuss is the differences between liner and shaders. One of the most distinct things that you will notice about these two machines is the spring lengths, mainly the front spring and the placement of the contact screw. The liner has a much shorter front spring and the contact screw is noticeably further back on the machine. The contact screw on the liner has an angle of about 30 degrees and is placed almost over top of the front coil. Also, the gap between the contact screw and the front spring are much smaller than the gap of a shader. The gap of a liner is approximately the thickness of a dime, when the gap of a shader is around the thickness of a nickel. The shader has a much longer front spring, and the angle of the contact screw on this machine is around 45 degrees. If you notice the placement of where the contact screw meets the front spring, you will see that it's almost directly over top of where the needle bar is attached to the armature bar. Now that I've shown you the differences, I will explain why these machines are set up this way. The shorter spring, placement of the contact screw, and the gap from spring to screw on a liner definitely serves a purpose. This type of setup is to make your machine run a specific way. Basically, it's the reason that this machine is a liner. This will make the machine run a little faster and more consistent. So when you're doing your line work, it will assure that you're putting in a nice, clean, solid outline, and that's what we're really striving for. Now let's talk a little bit about the shader. There is a reason that the front spring is much longer, the contact screw is placed over top of the needle bar, and the gap is much larger for this machine setup. This is set up so your machine will have a much longer stroke. This is vital to assure that your color work will go in solid and your shading will come out smooth. Of course, technique has a lot to do with this, but if your machine is not set up properly, it could be a battle for you. So with this spring setup, it will make the machine run much differently than a liner. First of all, the shader does not have to run quite as fast as a liner to do its job. And because of this longer stroke, the spring of the machine will have a little more give or kickback. This will help make your shading and color blending much smoother.